For our next example, we have here a 500 kilogram vehicle mounted on springs such that its static deflection is 1.5 millimeters. So let's try to write our given first. We have a mass is equal to 500 kilograms. So this is the mass of the vehicle. And we have our static deflection represented by delta. Now let's try to represent our deflection with delta, which is equal to 1.5 millimeters. Then we're asked to find what is the damping coefficient of a viscous damp to be added to the system in parallel with the spring such that the system is critically damp. Okay, damping is already considered here. The system is critically damp. So sa may naani. So let's know we have the natural frequency of the system, which is equal to square root of the stiffness over the mass. Next, if you remember, the stress is equal to the modulus of elasticity times the strain. And we know that stress is equal to force over area, and then the strain is equal to the deflection over the original length. Here, ingon niya, si 500 kilogram vehicle that is mounted on springs such that its static deflection is 1.5 mm. So the vehicle is being mounted on a spring. And then there is a significant deflection, static deflection equal to 1.5 millimeters. So, ay mo katingalang anong delta na sa itong deflection. So, the force here sa ito ang Hooke's law, that is just, so yung gina-resist na force is the mass or the weight due to the vehicle, that is just equal to the mass times the gravitational acceleration over the area is equal to the elasticity times the displacement over the length. Now, we write this in terms of mass. We have EA delta over GL. So if you notice, no, we have the EA over L here. So this is like the actual stiffness. So we have the modulus of elasticity times the area times the displacement over the gravitational acceleration times the length. So ano ato man gikuha og relation? It is because, so let's say if this is our equation 1, this is our equation 2, we substitute equation 2 to equation 1. But let's have another equation sa in terms of the stiffness K. Stiffness K is equal to EA over L. Well, let's say this is our equation 3, and then let's substitute this again to equation 1. So we will have our natural frequency, this is equal to the square root of, so we have K over M or EA over L over the mass, which is equal to EA delta over GL. So makanswer si A, si L po og si L. So we are left with natural frequency, which is equal to square root of the gravitational acceleration over the displacement. So, so ano magkuha tag omega? Na mo gina-mention diri nga system is critically damp. So sa may pasabotan ng critically damp. When your psi is, diba, is equal to 2 over C over 2m omega. And then, the system is critically damp when the damping ratio is equal to 1.0. Or that your damping coefficient is equal to 2m omega. So, mo man siyang critically damped. So, ato ni siya og si 2m omega. So, we have here 2m omega over delta. So, ato na siya mo-solve. We have here the gravitational acceleration. We have the 9.81 meters per second squared over the deflection. Our deflection is 1.5 millimeters or equal to 0.0015 meters. So be careful of the units aron makasa na to si meter nga duha. Then we will have our natural frequency omega, which is equal to how much? Square root of 6,540 per second squared or equal to 80.9 radians per seconds. So ato lang na substitute diri, then we will have our damping coefficient. So 2 times mass, which is equal to 500 kilograms, times 80.9 radians per seconds. So we will have a damping coefficient equal to 8,900 kilograms per seconds. Again, kilograms per seconds is just equal to 80,900 Newton seconds per meter. So this is the critically damped nga C. So, mo na siya. We're asked to find the damping coefficient man. Damping coefficient is C. And then ingon niya such that the system is critically damped. 2m omega. So, mo na siya to answer. 80,900 Newton seconds per meter.